Hopefully my screen is visible. Okay, guys. Today we are starting with our Docker meetup. Screen is visible. Just 1 minute. Okay, guys. Today we just facing an audio issue. No, it's fine. Okay. So today we are starting with our Docker meetup. This meetup is majorly based on a session of Minio, which will be conducted by Ashish Sinha. He is the community contributor, and Nitish Tiwari, he is the software engineer at Minio. So I'll pass on to them in a few minutes, so they'll introduce themselves, their work, and get started with the session. Um, Upcoming meetup. So I just wanted to give you an update. We'll have the next meetup on 28th of July. So there will be two meetups on 28th of July. One will be a physical meetup that is at the App Orbit office in Aun, and one will be the online meetup based on the DockerCon session on Dart. So we'll have two meetups on 28th. And other than that, we've started a YouTube channel for Docker Pune. So we'll be publishing all the online sessions and recordings on the Docker Pune YouTube channel. So make sure to subscribe it to get the latest updates. So yeah, that is it from my side. And Nitish, you can share your screen now and get started with the session.
Sure, thanks, Aarti.
Thank you.
Thanks, Aarti. Good morning, all. I'm Ashish Sinha, an open source enthusiast with around 8 years of experience in IT industry. I have been contributing to Minio recently. To start with, I would like to say what is Minio. Minio is an object storage server compatible with Amazon S3. It is best suited for storing unstructured data, be it photos, videos, log files, backups, containers, VM images, and everything and what you can think of as unstructured. The size of the object does not affect us because it ranges from few KBs and to a maximum of 5 terabytes. Before getting into Minio, let's start understand what object storage is and what kind of data is best suited for Minio. Traditionally, web application used to store file systems and databases to store user data in a track in the backend. It was simple structured data. Like if you take, for example, if you take the Oracle, it was something of a structured in which the data were stored in rows and columns. This was easy to manage since rarely an application generated unstructured data in the earlier times. But nowadays, most of the application does generate unstructured data, be it Facebook or WhatsApp chat, what you have, the server logs which you want to store. All these are something which is unstructured and you want to store it, which we're not able to store in the traditional data warehouses. Times are changing with the advent of social media, cloud storage, data analytics platform, and other computing paradigms. More and more unstructured data is now being pushed onto the internet. So, unlike the files in the file systems, objects are stored in flat structure. There is just pool of objects, no folders, directories, or hierarchy. You can simply ask for a given object by presenting it keys. So when you are trying to store an object as an object on an object storage server, you just have the whole data as an object along with it keys there, which is the object ID. Apart from that, the metadata is also present out there, which states what type of data it is, what is the origin, what is the size of the data, and things of that sort. Now, to state my experience, I have been working for about 3 years into big data technologies and basically data lake. So, what all things which I have faced there, I would compare the object storage to SDFS here. Have used MapperDB, Hive, Pig, HBase. Initially, it was a smooth thing because there were almost the production cluster was of almost 50 nodes, and we used to store the data. But more and more inbuilt companies started dumping the data onto the data lake, and the size grew. The problem what we started facing was the size. We added few more cluster nodes to the cluster, and the production was about 50 nodes cluster. But then there was server patching, OS upgrades, application downtime, which leads to the failure of scheduled jobs. And this was the bottleneck which I used for about 3 years. So we started for object storage. And here is what Minio is. Minio, on the other hand, runs on private infrastructure and is easy to scale as the data grows. So you don't have to worry about the size of the data. It's just the infrastructure which you have to give it. And on top of that, Minio sits and takes your data and pushes down into this structure, private structure, what it is you have. Since Minio is S3 compatible, it offers a single storage platform for customer facing applications that brings in data with analytics platform like Spark. You can integrate Spark on Minio and find out what the data you have, or you can do the analysis on that data. Okay. Moving on to the next slide, which talks about the Minio stack. The Minio consists of three things: Minio server, Minio client, and Minio SDKs. Minio server is actually a S3 compatible server that runs on your private infrastructure. Minio client is a CLI tool that interacts with the server. It offers several specific features like healing, searching, backup, and the complete bucket lifecycle management of or data is stored. Along with this, it contains the Minio SDKs, which is written in different languages like Go, Java, JavaScript, .NET, which you can integrate it and then push on your data onto the server. This slide tells you about the erasure code and the bitrate protection. Minio uses erasure coding to ensure that you have a data redundancy built in when you store data in Minio. Actually, Minio uses a bitrate protection to ensure that there is no salient data corruption. You could find data out that whenever the data is stored on any file system, it start getting corrupted and slowly data you are losing out the data. But Minio actually uses the erasure coding as well as the bitrate protection is there. And the checksum is also there, which actually finds out that the data is getting corrupted, and it ensures that you recover the data what is present out there. For example, if you have a 12 drive setup in Minio erasure code, you can lose as many as 6 drives and reconstruct the data reliably from the remaining drives. In contrast to this, if you're using a RAID 6 infrastructure, then you can just recover 2 nodes from the data which you have stored in. So this is something which you can take it as a good point with Minio, that is even though you have kept the data for a long and you don't have to worry about the data being lost because it's regenerates the data even if you have lost half of your hard drives. Now moving on to the cloud native architecture. The term cloud native resolves around the idea of applications deployed on as microservices that scale well. A cloud native application is portable and resilient by design and can scale up horizontally by simply replicating. Modern orchestration platforms like hello, hello.
Yeah. Yeah. Hi. Hi, Ashish. Just 1 minute. I'll just tell everyone. Can everyone else go on mute, please? Yeah. Thanks, Ashish. You can continue. Yeah.
Yeah, to say about the cloud native architecture about Minio. A cloud native application is something which is portable and resilient by design and can scale up horizontally by simply replicating. Modern orchestration platforms like Swarm, Kubernetes makes replicating and managing containers in huge clusters easier than ever. While containers provide isolated applications execution environment, orchestration platforms allow seamless scaling by helping replicate and manage containers. Minio extends this by adding isolated storage environment for each tenant. Minio is built ground up on a cloud native premise with features like erasure coding, distributed and shared setup. It focuses only on storage and does it very well. So you don't have to think about the replication and all. You just have to deploy Minio on a Docker and everything, all this orchestration tool like Swarm or Kubernetes helps you in applications deployment as well, in and the application deployment. Minio is built ground up on a cloud native premise. Okay. Scalability is not a function of the application, but the orchestration platform. So the scalability of Minio is done by Swarm and Kubernetes. Minio does not look into that. It is just an object storage, and it does pretty well for that. Moving on to the object event notification ecosystem, I would like to tell that Minio is already integrated with many systems in which gets notified whenever you create an object. Like you're creating a bucket on a Minio server, and you are telling that once the bucket is created or the object is put into a bucket, different notifications should go to different environments. Like you can have that Postgres, MySQL, Kafka, all integrated. Just the configuration which you have to make, and all these endpoints, the subscriber in means will be listening to it, and it will get notified that object has been created or the object has been deleted or whatever there you want to have it in the configuration file. Now, to tell about the Minio usage and its worldwide foothold, as you can see from the slide itself, that it's quite famous across the globe. If you're wondering how popular it is, then the stat says it all. To give you the stats, it's about more than 100 million plus Docker pull, 12,000 GitHub stars, 100 plus contributors, and around 3,000 members in the Slack channel as of now. So this is all about Minio, what we have talked about with the slides. You can have Minio on the website. All the documents are present. How you can put Minio on Docker or Kubernetes. Even the blogs are present where you can read the use cases as well as the deployment of Minio. For now, we will be doing the demo sessions.
Hi guys, so this is Nitish here. I'll just show you a demo of how to run Minio on Docker. Like I'll be running Minio on a standalone mode. And there are multiple modes actually that Minio supports. There is erasure coding, there is gateway, but we'll be doing a demo of standalone mode. And if you're interested, you can actually join our Slack channel and we all of us hang out there. And if you have any questions, we'll help you out. So this is how you run. So this simple Docker run, and we are mapping the port 9000 of the container to our host 9000. We are passing the access key and secret key via environment variables, and then we are mounting this local host drive to Minio container drive / data, and we are mounting the config drive to /root /Minio. So now you can see the server is up. So now you can actually access our Minio browser. Let me show you the browser. So Minio actually comes bundled with browser UI. So you, as soon as you start Minio, you can actually access this browser. So let me just create a bucket. So you can see there is a bucket created, and I'll just upload a file. So the file is uploaded on your server. Let's so we Ashish talked about Minio client. So let me show you Minio client as well. So Minio client is actually CLI tool which is built specifically for Minio. It also works with S3 because Minio S3 they are all compatible. But there are a few features like healing which are specific to Minio. And so I'll just show the bucket that we created on the browser. So we created a bucket called my mini test bucket, and you can see the bucket is available here. So let me so let's see what's inside this bucket. You see, I uploaded this object, and it's available here. So anything? Okay, let me try to upload something from here. I'm uploading a file from localhost that is readme to the Minio server, and it will be called as test file. So it will be now visible on the browser as well. So these are basic things, but if you have any use case in mind that you want to deploy Minio on, you can actually always join us on Slack, or you can even come to GitHub and just ask questions, and we'll actually help you out. So right now, if you have any questions, I'll be happy to help you.
Nitish, there are a few questions.
Okay.
So there is a question that does Minio work as NFS? How about data latency?
Yeah, so Minio actually runs as a gateway on NFS. You can actually point NFS mount to NFS Minio gateway, and you'll have S3 compatible UI on top of your NFS backend. So Minio works very well with NFS.
Um,
So actually, we have NFS gateway docs as well. So if you can actually go to the site, and you have actually detailed documentation on how to do this. There was another question you're telling.
so I wanted to ask that how different is it from other object storage that we have already?
Yeah, so Minio actually the major difference is the design philosophy, how Minio thinks about scaling, and how Minio does stuff like how Minio actually does replication, for example. So Minio actually for scaling we always recommend the multi-tenant setup, where you actually, instead of building one big storage server for everything, we recommend single instances for specific tenants. So this way you build small blocks of storage, and you can scale infinitely as long as you have storage infrastructure available. Instead of the problem with, for example, SDFS is it's one big block of storage, and application see it as one big storage backend. The problem with that is once you start scaling, you will hit a limit where it's no longer possible to just scale it without having downtime or without having operational issues. Minio on the other hand has small instances that you can deploy per tenant and just keep on growing. We also have a federation feature where actually multiple instances can be seen as one, but that still is based on single instances which are actually just cooperating instead of one big instance doing everything.
Okay. There is another question that can you show us how data persistence takes place, like how we strategize, how we can use it for persisting data?
So for example, in the demo that I showed, Minio, actually we are just giving a directory here that actually has the persisted data. So in production environment, instead of directly, this will be a disk mount, which will actually map to a Docker container. In Kubernetes, it will be a persistent volume, which will be mapped to the Minio container. And the data actually goes and sits there. Minio provides the S3 layer and all the replication, all the data management. You don't have to actually go to the backend, but you can actually provide a disk, and Minio will write the data to the disk.
Is Minio compatible with Google Cloud?
So Minio actually, Google Cloud itself is not S3 compatible. They have interoperability mode, but there are few corner cases which actually don't work with S3 as well. So what we do is we have a gateway mode for GCS, Google Cloud Storage. So what you can do is you can have your GCS backend and you can run Minio as a gateway, and Minio will provide complete S3 compatibility to your GCS backend.
Okay. Guys, if there are any more questions, you can start pasting them in the YouTube chat, as well as if anyone in the Hangout call wants to ask questions to the speaker, they can do so. Meanwhile, Ashish, Nitish, can you elaborate on the bitrot and the erasure checksum that you had shared us earlier? Can you elaborate on that a little more?
Right. So actually, erasure and bitrot have two specific use cases. So bitrot actually targets the cases where disk actually goes corrupt silently. So you may have seen cases where a few sectors gone bad, and you can just recover few certain data points. Right. So what happens is Minio actually maintains a backend checksum for each block of data, and say that while each read, when you issue a get object, you will see that whenever we are going to read onto the disk, read from the disk, we'll see that the checksum matches. If the checksum doesn't match, we'll actually then try to recreate the data using erasure coding. So I'll come to erasure coding, but this what bitrot does. It makes sure that even if there is silent corruption going on in the disk, or like disk is slowly getting corrupted, you don't lose the data. So erasure coding, on the other hand, actually it's a very generic mathematical algorithm that lets you recreate your bits from certain data and parity bits. So, for example, if you have a 8-disk setup in Minio will by default store 4 disks as data and 4 disks as parity. Now you can lose any of these 8 disks. It's not like you lose data, or you lose parity, or then only will be able to help you. You can actually lose any of the 4 disks, any of the 8 disks in any order, and still, if you have at least 4 disks available, we'll be able to recreate the data back and give it back to you. So what is happening is, instead of the 3-way replication, where the say if you are storing 1 GB, you need actually 3 GB of storage. Needs only twice the storage space to give you double the replication. So that is erasure coding.
Okay. There is another question that does Minio support cross-region replication?
Yes, so cross-region replication, actually what happens is, if you actually this here MC will come into picture. Generally what happens is, you have like Minio setup in one region, and then you have Minio setup in another region. One is primary, one is secondary. Then you can use Minio client's mirror feature to actually mirror data from one region to the other region.
Okay.
And I see there's a question about PCF. So actually, Minio is very well integrated with Pivotal Cloud Foundry as well. You can actually, we have docs on PCF as well. We release tiles for PCF. So if you are interested, you can actually just go to the doc site, and you'll see details on PCF as well.
There is another question that, other than Minio client, do we have an API?
Yes, so Minio actually exposes S3 compatible API. You can use Minio SDK, or you can use even AWS S3 SDKs, whatever language you are using and whatever SDK you are comfortable with. You can use that SDK, integrate with your application, and send request to Minio server, and it will work.
Any more questions from anyone? Um, um, Nitish or Ashish, can you just give like a real life example or use case where like you've used Minio at a customer side, or can you give us an example of how Minio was scalable and at what level it provided data integrity?
So for data integrity, we use the erasure coding, and there are actually many. So more than 100 million Docker pools are already been made, and there are many actually. Since it's open source, it's difficult, point out about customers or users because it's free to download. It's free to download and anyone can download and use it, so it's difficult to point out about customers right now, but we have actually many users, and we have been getting questions on Slack about setting up. So I don't have any specific customer to point to right now, but Minio is being used at petascale level to actually store data. That is, I can say from confidence.
Okay, cool. Also, can you just guide our attendees on how to contribute to Minio?
So you can actually go to just our GitHub, and we have detailed contribution guidelines. You can read that, and even if you are like not not very comfortable with Go or any other language, we'll actually we welcome contributions always. So we'll actually help you out if you have any problems, and we'll help you contribute. So you can just go to GitHub, see there are lots of issues already. You can just pick any issue that you think you can work on, and you can just ping there. Like you can just comment there saying that. This is my this is what I want to work, and then someone will from the team will help you out, like how to contribute and what to do in that specific issue.
Okay. Other than that, attendees are just curious about how they should get started with Minio. Are there any like examples in your documentation or some other training site or something?
Yes, so as soon as you land on the documentation page docs.minio.io, the first page actually helps you with the get started basic setup. It's actually it will just take few seconds if if you just copy and paste the commands, it will just take few seconds to get up and running. You already saw I ran Docker Minio. It just took few seconds, so it's actually very easy to get started with, and you know. Anything else you can always ask us and we'll be helping you out. There are no books as such right now, but we have detailed blog site where we actually regularly put information about new integrations, new features that we are working on. So you can follow our blog, and there is a lot of information there as well.
Um, are there like any more features or advanced capabilities that you provide in Kubernetes? Is there something different than what is there in Docker?
So we already have a Helm chart for Kubernetes, so it's easy to deploy. We are also working on a Kubernetes operator that will provide you self-healing kind of setup where if there is a downtime, you will heal itself. And we are working on integration with SSOs like single sign-on stuff. We are also working on federation. I talked about federation. So federation is actually multiple Minio instances. Like they all behave as one namespace. We also have a feature where you can actually start on like any number of disks on a Minio server. So it's not limited to 16, or it's not limited to any specific number. You can actually start Minio with as many disks you have. So there are actually several, enterprise kind of features that are available, or they are actively being worked upon as we grow.
Okay. And for an enterprise level, do you have like a hardware recommendation of what disks should be used, or do they need to be backed up regularly, or is there any recommendation from Minio?
For backing up, if you are using erasure coding, it's already replicated, and it's you can lose as many of half of the disk, and so there's no need to actually back up if you're using erasure coding setup. Otherwise, if you are using a standalone setup, it will be better to have a backed up setup. For disks, specific disk hardware, we have actually all this recommendation on our GitHub docs. So you can just go Minio and then docs directory. We have detailed specifications on like recommended hardware and recommended file system and
Okay.
everything. Yeah.
And in terms of memory usage, how would you scale Minio?
So Minio has a fairly small memory memory requirement. So as long as like we actually actively make sure that there's not much load on RAM. So the what do you call it? Memory footprint is actually small. We have a detailed blog on Minio benchmarking with Costbench. Costbench is a cloud benchmarking platform. It's from Intel, and we benchmarked Minio on Costbench sometime back. So detailed specifications are available there. I'll just paste the link, so that will probably help getting an idea about Minio's performance.
Sure. Any other questions, guys?
I just pasted the cost benchmark details on the Hangout chat, so interested people can take a
Yeah.
look.
So there are a few questions for related to the code base in Minio and the GitHub link. I'll be sharing the GitHub link as well and the code base details as well. Other than that, I don't think there are any more questions. Um, I think Nitish, Ashish, do you have anything else to share on this?
No, right now nothing. Just thanks a lot for hearing us out, and thanks for these great questions. We look forward to seeing you on GitHub or Slack. Or
Sure. Thank you so much, Nitish and Ashish, for taking out time and sharing your knowledge on Minio with us. Thank you to all the attendees for taking the time to listen to this session and attend the meetup as well. As I had said in the start of this meetup, we'll be having the next meetup in Aund on 28th of July. So do RSVP and attend it as well. And we have started a YouTube channel. So this session will be is recorded and will be available on the Docker Pune YouTube channel as well. And if you have any queries or questions, you can paste them down there. I will make sure that these queries and questions get answered from Nitish and Ashish as well. Yeah, I'll be sharing all the links as well. Also, yeah, a small update that Big Binary is organizing a Kubernetes workshop in Pune, so I'll be pasting a link to that as well. So, if you guys are interested in great Kubernetes session, do join Big Binary on 10th of August. Thank you so much. Thank you all. This will be a wrap, and I'll be providing all the links and documentations and the recording as well. Thank you so much. Thank you, guys.
thanks, Narti.
Thanks
Thanks,
a lot.
Dr. Pune.
Thank you. Thank you, Nitish. Thank you, Ashish. Thank you.